Hi there, welcome to my channel. In this video, I am going to discuss about the solution for converting an integer to Roman. Let's look at the problem description. We are given an integer and we have to convert that into a Roman numeral. So there are 7 different symbols in the Roman numerals. And the rules for converting from integer to Roman numeral is if the current number starts with 4 or 9, then we have to use the subtractive form. Only the powers of 10 can be appended consecutively, and also that maximum 3 times only we can add. Okay. If it is not starting with 4 or 9, then we have to pick up the maximal value that can be subtracted from the given number and add the corresponding Roman numeral to the output. Okay, let's take a look at the example 1. So the given number is 3749. For 1000th position, we have 3000. So we can subtract 1000 3 times from this number. So we add 3 m's. Then 700. We can subtract 500 from the 700 and then 100 2 times. So that's why we see DCC. And then we have remaining 49. So in that 40, we can represent 40 as per this rule XL. So XL is added. And then we have remaining 9. So that 9 is represented by IX. So if we combine all of them, 3M DCC XLIX. Okay. And similarly for the example 2, we have 58. For 50 we have L, and for 8 we can subtract 5 from this, so V, and then the remaining 3 we can add 3 ones, so I. Okay. So the constraints are the given number will be ranging from 1 to 3999. Let's look at the approach to solve this problem. First we have to create an integer Roman pair for all the Roman numerals and its corresponding integer value. So in addition to this 7 Roman numerals, we have the subtractive form of the Roman numerals also we included in this array. For example, if you see 900, I have that CM as the value Roman numeral for that 900 integer. So likewise for 500D, 400CD. Okay. So the key thing is this array should be in the descending order of the integer value. So first entry should be the highest integer value Roman numeral, which is 1000, and then second one is 900, so all the way to 1. Okay. Once we have this array, we can iterate over this array from the 0th entry to all the way to the end of the array, and each entry we try to subtract it from the number. If the value of the number is greater than the current pair, then we subtract that integer from that number and add the corresponding Roman numeral to the output string. So each time we try to subtract as many times as possible until the current value of the number is less than this current pair integer value. Okay. Once we reach that condition, we break out of that inner loop and then we process the second entry in the array. Likewise, we keep it repeating. Starting from the highest value, we subtract from the number, we all the way go down to the integer value 1. Okay. So that's what I listed here. First, create an array of integer Roman numeral pairs in the descending order of the integer value and initialize the result variable with the empty string and traverse the elements in the array, and each time we try to subtract this current value from the input number if the input number is greater than the current entry. We repeat that until the current number's value will be less than the integer value in the pair. Then we move to the next iteration. By the time we reach the end of an array, the input integer number is converted into a Roman number. Let's look at the flow chart. Input for this procedure is an integer number. First we initialize the string variable called Roman, and then we create an int Roman pair array, and then we traverse the int Roman pair array. We check whether we processed all the entries in that array. If so, we come out and return the Roman string. Otherwise, we check whether the integer value in the current pair is less than the number. If it is less than the number, then we subtract that int val from the current number. After subtracting, we add the Roman numeral to the output, the Roman variable. Okay, we repeat that as long as the current number is greater than the integer value. If it is less than, then we break out of the loop and then we increment the index to process the next element in the array, and we repeat the outer loop until we process all the entries in the int Roman pair array. Okay. Once everything is processed, then when we come out, the Roman string will have the Roman number for the given input integer value. Let's move on to coding. First I declare the int Roman pair structure, which has the integer value and the corresponding Roman numeral in a string format. Then I define an array of integer Roman numeral pairs, which includes all the Roman numerals, including the subtractive form, and in this case all of them are in a descending order of the integer value. Then I define the strings builder object called Roman. Then I write the outer for loop which range over the int Roman pair array. Each iteration it checks whether the current entry's value is less than the current number. If so, it subtract that value from the number and add the corresponding Roman numeral to the Roman string builder object. And finally I return the string from the string builder object. Next I'm going to run the test cases. Okay, all the tests passed. Next I'm going to submit this program. Cool. This program is accepted. Next I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So the number given is 1952. The expected output is MCMLII. So in this int Roman function, first we create an array of integer and Roman numeral pair in a descending order of the integer value, starting from 1000, 900, 500 all the way to 1, and the corresponding Roman numerals. Okay. Then we initialize the string builder object, Roman. Okay. So in the outer loop iteration 0, we pick the first entry in the array, first element in the array, and we check whether that with the given input number is greater than that val in that entry. In this case, yes it is. So we subtract that number and add the corresponding Roman numeral to the output. Okay. When we leave this iteration, the number will be 952 and the Roman string is M. The iteration 1, we have 900. So in this case, the current number is greater than or equal to 900. So we can subtract this number from the 952 and we get 52, and we add the corresponding to the Roman string CM, MCM now. Then in the iteration 2, we have 500, but the current number is 52. So we cannot subtract. So we move to the next pair. So here it is 400. It is still greater than the current number. So we cannot do anything. We move to the next number. 100, we cannot subtract from 52. So we move to the next one. And 90. So this also we cannot do anything. So move to the next entry. So now this number is less than the current number 52. So we subtract 50 from this number. Now the number will be 2, and we add the L to the Roman string. Next we have from 40 to 4, we cannot do anything. So when we leave the loop body, the number and the Roman numeral will be same for the next 4 or 5 iteration until we reach the entry which has the value 1. So now 5, same value, 4, same value. Now we have reached the last entry with the integer value 1. So that is less than the current number's value. So we subtract this from this number. So we have the remainder 1, and we add the corresponding Roman numeral to the Roman string. So now we have MCMLI. In the next iteration of the inner loop, we still can subtract the current integer value from the number. So we do subtract and we reach the number become 0, and we add that I again to the Roman numeral. Finally we get the MCMLII, so which is an expected output. Next I'm going to do the time and space complexity analysis for this solution. In this function, the main operation is subtracting the integer value from num and then adding the Roman numeral to the output. Okay, let's see how many times this operation is done for any given input. Let's take a look at the case 1, where the input number is 1952. For this, how many times this operation is done? For 1000 we do once, for 900 we do once, for 50 we do once, for the value 2 we have to add the Roman numeral of 1. So totally 7 times this subtraction and appending operation is done. Okay. And for this case where all the digits are 3, okay, so for 3000 we add the Roman numeral for the integer value 1000 3 times, and for 300 we add the Roman numeral value of 100 3 times. For 30 we add the Roman numeral for the integer 10 3 times. For the value 3 we add the Roman numeral of integer 1 3 times. So this is the worst case scenario. Okay. In this case this subtraction and the appending operation is done 12 times to generate the Roman numeral. So this time complexity depends on the value of this number, but maximum the total number of entries in the int Roman pair array, because the constraint is the numbers will be ranging from 1 to 3999. So this also a part of an input. We can do the time complexity in terms of the number of entries in this input array. Okay. So in that case the time complexity is order of n. So the worst case scenario, that maximum number of operation is equal to the size of this array. It cannot be more than the size of this array. So the time complexity is order of n. With respect to the space complexity, we created this input array, but the size of this input array does not change based on the actual input given to this procedure. It remains same. And also we do not allocate any additional space. We allocate space for only the output data, so we can exclude that from the space complexity analysis. So the space complexity for this procedure is order of 1. Thanks for watching this video. Have a great day.